Hello traders, I'm Miroslav Popov and I make backtesters. In that video I will show you what is an execution chain and why we want to break it. So basically execution chain is the sequence of orders. As you know, a strategy performs long and short trading as a result of the trading rules. Here we see the balance curve as a result of the backtest of this strategy. We can see the orders in a report, journal. We see here long entry, short entry, long, short. The first entry is long. We can also see the orders in the indicator chart. I'll press the home key to return to the starting of the backtest. The backtest starts from that bar where the mouse is, and the first long signal is just here. And this trade finishes on profit. The problem is that the generator is so powerful that it's possible to adjust the strategy parameters in a way to have the perfect balance curve. We call this our optimization or curve fitting. But during that position, it is completely possible to have other orders for long or for short entries. If there is another long entry and we skip the first one and open long somewhere here, for example, it will also finish on profit. But what if it was a short entry? Let's see if there is some such order. I'm moving the mouse along the chart and try to see such entry. Okay, here. We see that both indicators shows sales signal. So if we are skipping the first entry and we start the backtest rate, it's completely possible to have a short position from here. And obviously, this particular short entry would close on a loss. How many such shadowed opposite orders we have? We don't know. That may be only a few, but that also can be hundreds of such orders. In order to examine such cases, I added additional algorithm to Monte Carlo. Let's go to Monte Carlo. We have this randomized backtesting starting bar simulation here. It traditionally starts the backtesting in different positions and examines what happens with the strategy. But now I made this simulation much cleverer than before. Let's test it. I'll remove all other simulations and leave only this one. And if I run it, we see that this particular strategy performs very well. What exactly this simulation is doing? It skips the original entries and tries to start the backtest from an opposite order. We see that this particular strategy performs very well and all simulations finishes on profit. But this may not be the case for all strategy. Let's check another strategy. Let's see that one. Monte Carlo, run the simulation. This is also very well. Here is an interesting case. The balance curves here in that simulation are results of opposite entries. And we see that this opposite entry finishes on profit, but this particular one finishes on loss. It would be very bad if our strategy is subject to failure when we start the backtest or real trading on different position. Let's examine some more cases. Let's see this strategy. This is very interesting also. We see that some simulations go up and some of simulations go down using this randomized backtesting starting bar. However, this is not all. We can use this simulation in the reactor. Let's go to the reactor. By default, it is set 80% of the validations to pass. Let's try it with 100% of the validations. The reactor uses the same settings for Monte Carlo as the individual strategy. So let's return back, go to validations. It by default requires 100 count of trades and a minimum $10 of profit. But I'll remove this and I'll set it here 0. Because what happens that when you run the randomized backtesting starting bar, it starts the backtest rate and it leaves a shorter backtesting period. Let's run the reactor to see what will happen. We already have several generated strategies. When the reactor generates a strategy, then it passes through Monte Carlo, and only a few of them pass the Monte Carlo validation. But what I will do, I delete the current collection because I want all the strategies generated by the reactor to pass the new validation. Let's wait a little bit to have such strategy. Already we have one. Let's see that this balance curve is not very good, but I will use this opportunity to show you something other. Let's go to Monte Carlo and run the validation. This is interesting case because we see that these runs are going a little bit better than these ones. Why this is the case? Let's go to the editor and see the balance curve. This is the balance curve of this strategy. We say that this strategy is running rather well here, but here there is a long period of stagnation, and also it has a drawdown. Actually, when we randomize the starting of the backtest, we have two effects. The first one is what I already described, trying to break the execution chain by starting with the opposite order. But the other case is that when we start in different position, we experience different modes of the strategy. It looks like the market was more favorable for the strategy here, and during that period, the strategy doesn't trade very well. If you start the backtest before this local top, we will have a profit. But if you start anywhere here, we have a loss. So when you run this simulation, it also examines if the balance curve is linear and stable enough. But this is not the primary goal of this simulation, because if you use R-squared validation criteria, we can easily examine the linearity of the balance curve. Let's stop the generator and see more cases. This particular strategy also passes the validation. How this validation works? First, when you start the Monte Carlo, it examines the initial strategy and searches the backtest for such cancelled opposite orders and start from there. But it does this only in the first 70% of the data, because it keeps some of the data to give a chance to the strategy to recover. I think this is fair enough. If there is no enough such opposite orders, the validation continues with random starting positions, just like it was before this update. We can use this option as an individual test, like in that case, but the Monte Carlo provides also other validations, and it tries to randomize historical data here, and also it can increase the spread and slippage to examine the different aspects of the strategy behavior. We can use these simulations individually, and also we can combine these ones with the new ones together. However, I think this is too strict for the strategy. What happens is that this option reduces the length of the data series the strategy is tested. But these options are designed to examine the behavior of the strategy for the complete backtest. So my humble opinion is that we may use these options as an initial test, and just before exporting a strategy, you may switch off this and run this simulation just to be sure that the strategy behaves well. I particularly don't like this strategy because I see that some of the simulations go, but there are many simulations before the starting balance. Let's see other cases. I think this strategy is better because it has less time below the starting balance. Thank you for watching this video till the end. Please subscribe to the channel and put a thumb up to the video. Bye bye.